Hello, everybody. This is Charlie Frick from IACD, welcoming you to another one of our Integrated Adaptive Cyber Defense webinars. Very excited today that we're going to have Kumar Saurabh from LogicHub and Rocky DeStefano from Visible Risk talking about decision automation. I think it should be a really good conversation, and we'll be following things online. If anyone has questions, feel free to post them in the comments. And with that said, I'd like to introduce Kumar. Kumar, thank you for coming here today.
Thanks, Charlie. Awesome. So it's really great to talk about decision automation in general, and security automation. And I'm excited that we have Rocky on the call on this presentation with us to talk through. He has been looking at SOCs in general and number of years of experience. My own background has been, I've spent 15, 20 years working with security analytics, SOC platforms, and for the last 3-4 years, focused very heavily on security automation side of things. So I'm looking forward to digging into a little bit more of detail very soon. Rocky, would you want to introduce yourself and then we can dive in?
Certainly. So, Rocky DeStefano, and thank you all for allowing me to be here. Similar to Kumar, 20 plus years, really focused on defending the enterprise, helping bring products to market, ArcSight, NetWitness, and then on the cybersecurity side of Cloudera. So I've been involved in this space, either building products and bringing products to market or running security operations centers. And I've run several very, very large ones from the Department of Justice all the way through many, many years ago, EDS's Managed Security Services globally. So pretty much my life is on detection and incident response and bringing solutions to bear in that marketplace.
That's great. Thanks, Rocky. And, both Rocky and I, when we have talked to a lot of security teams, in many ways, every security team, every SecOps team does things slightly differently, but there is a common pattern that we see across multiple enterprise security teams. And the very common thing, what you're not seeing on the screen right now is 30 or 40 different products that actually do prevention, identification, monitoring, visibility, all of that. But most mature teams will have some kind of either a SIM solution or a SIM solution augmented by a data lake where they're collecting a lot of data together, right? And in military, there is a common term used called the OODA loop, observe, orient, decide, and act, right? So for the purposes of this presentation, right, we're going to start with the observe layer, right? And you're observing, you're instrumenting, and you're looking at what's going on in your IT infrastructure with your applications, networks, devices, and you're pulling all of the data in one place. But in order for security teams to make sense of it, right, that's the orient piece of it, decide and then be able to act, here is the stack that we have typically seen. On top of these billions of events that many companies collect every single day, right, they would have some sort of detection logic that generates, a whole bunch of alerts, right? And if you're collecting billions of events every day, still, most teams don't have the capacity to deal even with hundreds of alerts every day, right? So you have to boil down billions of events into hundreds, sometimes thousands of alerts for very large teams. And then most of the teams, what they end up doing is all alerts are not equally important. All alerts are not hair on fire type of alerts, right? So there is a process of triage, alert triage that happens. And then out comes, a handful of incidents that really that get escalated to the CERT team. Right? So this is a very standard workflow, and the typical SOC that we see. Some of the teams most of the teams want to do threat hunting, And sometimes, people have the bandwidth a few hours a week, and sometimes they have a team of dedicated threat hunters. And where that comes in is how do we supplement and complement the rules that are in the system. And we'll talk about, how we can do automation on the threat hunting piece of that in particular. And I'll also introduce decision automation that comes very handy. But given that we have Rocky on the call, we figured that it would be a really good use to take a step back and see how automation plays a part in the SOC itself. So, Rocky, you have done a lot of work, talking to SOC teams as well, and getting a sense of which teams adopt automation, which teams have seen successes with automation. What have you seen in terms of general patterns, how people are using automation to quote unquote achieve excellence in SecOps?
Yeah, thanks, Kumar. In this first slide, I'll talk about 5 key drivers, and then the following slides will go in a little more depth about how security automation really has benefited from the proper structure and the proper teamwork. But this information isn't just, me and my simple observations. This is actually me interviewing 54 companies across the world, anywhere from Fortune 10 all the way through the Fortune 100 and into some of the smaller entities as well. So I had a good smattering across multiple verticals and had 50 different companies provide what works in their security operations center. And then I distilled those into the trends that we're going to talk about. So it's more than even just my experience. This is what the SOCs in the world are telling us. And really what they said was there are 5 really major areas where we can create success, measure success, and then ultimately instrument our ways to more and more maturity. And you do that by focusing on the right things. And the very first thing is focusing on the outcomes. And those outcomes really are simplified as how effective are we at our time to detect and our time to respond. And what they do is they relentlessly drive those numbers downward per use case. So per detection scenario, right? If I'm looking for malware via C2, there's a use case and there's a set of mechanisms and tools and data that's going to help me detect that. Well, in that, how can I get better? And these organizations focus very, very clearly on driving down the time to detect and the time to respond or contain. And they measure these individually per use case and in aggregate across the board. And this is what they report up, right? So they might say words to their board of directors like, in aggregate over the last 2 years, our time to detect malware is 8 minutes and our time to contain is 3 minutes. On average on a week-to-week basis. And this week we were, plus 5 minutes or plus 3 minutes. And we understand that the problem is X because of that. Driving towards outcomes, driving towards the right outcomes gives them the ability to very clearly state what the problem is and go fix it. The other elements really that we saw as key elements when we talk about excellence in the SOC was having people, and whether you call them very senior folks or superstars, there's some downside to using words like superstars, of course, but people that are focused and enabled to be successful in driving down those metrics, right? These people understand the business that they're protecting. They understand the context of what drives success for the business and therefore what drives risk for the business. And they understand the technical side of cybersecurity. These would be your hunters or people that help develop the strategy for what we should be looking at next. What we found is having a couple of those folks is super beneficial having one or two actually can create problems. You need a team of these folks to really lead you to success, so that it's not individually driven, it's driven as a decision process. And then the core of all of this is based on a framework, a detection framework. Something like MITRE ATT&CK or NIST or even a custom mix of these frameworks. And I'll talk about how valuable these frameworks are in a moment. But the idea is there's a service catalog, right, of SOC detection scenarios that exist now. And we can map ourselves to be able to say we cover these detection criteria or we don't. We have the visibility, which is the next key point, that allows us to detect this information, or we don't have that visibility. And it's a very objective measurement in saying we have coverage, we don't have coverage, we have visibility, we don't have visibility. We know what to do next. And then the other key piece is automation. The simplest way to describe this is if it's repeatable, we should automate it, right? So if an analyst is doing the same thing more than once, we should find a way to automate that function. And in so many cases, this automation is really context gathering, going and getting the rest of the information so that the story is complete, so the analyst doesn't have to do a lot of lookups. In the end, when we look at mature security operations centers, these are the 5 key areas. And of course, there's other areas, but these are the 5 key trends that fell across all of those organizations that I interviewed.
So, Rocky, one of the things that, especially in the last couple of years we have seen is, 2 years ago, right, you're seeing very few companies use security automation, use SOAR. What have you seen in these conversations? Is adoptions, what kind of patterns have you seen? Can you talk a little bit to that?
Yeah, so all of these security orchestration, automation, response tools are starting to gain true market traction, right? So initially it was seen as, this is a feature of a larger product. It's something that a SIEM should have been able to do, but never could get to. So there was some kind of pushback. And even myself, I was looking at these technologies going, is it enough to be a platform? Is there enough here? What we're finding is they solve a problem. And the problem they solve is either gathering context or automating away problems that they don't have to pay people to do anymore. So what we're seeing is 3 years ago, 2 years ago, you would have people adopting these technologies and implementing a single use case, right? It would be phishing. Every single time you would buy a SOAR and you would spend months implementing your phishing playbook. And that's it. And you had dozens of adoptions across the industry. And that was really it. Well, over the past 12 months, and this is proven by adoption in the marketplace of even acquisitions of these technologies, right? Looking at Demisto and looking at some of these others, and they've acquired by bigger companies because of the types of problems they solve. And it leaves room for more Switzerland-like players now to come in and really fill in the gap across all of these technologies. What we've seen over the last 2 months is more and more adoption of these. So the 50 companies that I interviewed across there, I had almost 25% say, yes, we are in SOAR. A year ago, there was one of those companies that was in SOAR. So a huge increase in adoption of these types of technologies because they actually can solve problems moving forward, right? And those problems aren't as abstract as just deploy a SIEM and we'll do SOC sort of things. They have very discrete problems and answers now, which is great.
That's awesome. And this is one of the things that I've seen, right? And this is tying in a little bit back to, like, where does SOAR go in? And one thing I almost point out, like, there is no D in SOAR, right? So SOAR is primarily focused around post-detection. You get an alert, okay, what do you do? But the problem becomes is like you can't respond to something you can't detect, right? If you never get that alert. And if you look across a variety of recent breaches, no matter like even if you go 5, 10, 20 years back, what you'll realize is that yes, in some minority of cases, the detection happened and someone did not respond, quickly enough. The reality is, like one of the stats out there is mean time to detect is 100+ days, right? And so many times what happens, you never detected the thing that actually bit you in the end. Because the things that you're able to detect, right, you can respond fast enough and automation makes that efficient, but there is also bigger gaps around detection. And this is where I think, the SOAR in itself, right, needs to kind of expand. The purview of security automation needs to grow beyond, what happens post-detection to include post-detection is very, very useful, and probably that's the first place people should apply automation to. But the other approach is like, how can we make threat detection better? And you have talked to a few teams about this, Rocky, as well. What have you found?
Yeah, so I'll tie in the slide that's up here into this whole conversation, which is the slide says of the organizations that deployed a detection framework of some sort, and then those that did not, how many new use cases, so how many threat detection scenarios did they deploy into production over the last 30 days? And what we found is those that have a framework typically deploy 3 times as many as those that do not, which really just stands to reason that, look, we have an objective path in front of us. We know what to do. We know how to execute versus, well, we'll figure it out along the way. And that approach, we'll figure it out along the way, has kind of been the approach of the entire industry the last 20 years, which is really based around the 1 or 2 people that we have in our SOC that know what they're doing and the best that they can do, right? So they're doing their best. But when we create a framework, when we create an objective set of criteria across the visibility that we need, the types of analytics, the types of threats, right, and the types of outcomes we're trying to drive towards, we can now start to prioritize these, organize these, figure out which ones are going to give us multiple sets of criteria to be successful with, and maximize the number of production use cases, meaning we get better coverage, more completeness, lending itself to higher levels of confidence and ultimately higher levels of maturity. Without these frameworks, there's no way to really get there or even measure that we got there. The other benefit of these frameworks is they lend themselves towards automation, right? We know what we're going to be doing. We know what data we can and should have. Let's work on ways to bring together the right set of information and predict what we should be looking at next, right? So we know which things have been helpful and which things have not benefited us at all. We have objective measurements of all of that information. We can bring that into automation logic moving forward. So that's this slide, and then the next slide, if we move forward, is how does SOAR, how do these tools interact with these frameworks and these number of detection scenarios that come into play? And what these companies were able to communicate to me was that if I'm using a SOAR, by and large, I'm getting 3 times as many use cases pushed to production than those that do not use a SOAR. Right, so a very similar correlation to frameworks and to SOAR. And I don't have it documented in this slide, but there's actually a very strong correlation to those companies that use frameworks are the most ready to move into a SOAR. Those that have no frameworks aren't typically mature enough, don't have enough visibility or enough understanding of where they want to go next to understand what they would automate, right? So it's a very clear readiness signal for automation if they're leveraging these frameworks.
Absolutely. And I think it's very interesting what you touched on, Rocky, right there, is that much of the SOAR or security automation, if I use a little bit broader term, obviously it started out with SOAR, right? But what you're talking about is threat detection using a framework like a MITRE ATT&CK framework, something like that is a great tool, is a great framework to build threat detection content for known scenarios, right? And that almost is like the second pillar or the second stage rather in applying automation, right? Yeah. So now you're applying automation to threat detection. And when I was talking to teams and maybe even a couple of years ago, there was still something missing, right? And I want to illustrate what was missing with an example. We do this cyber hunt challenge, right? So we took a server, we compromised it, we had root access to that machine, we collected all the log data and all kind of data around that, and we gave it to a lot of security teams that had, the leading SIM deployed and all of that, and said, if you have the right detection automation built in, you should be able to detect such a blatant attack and such an obvious attack within a few minutes. Like, how long does it take for a rule to fire? Like, less than a few seconds. So in 5 minutes, you should be able to tell me exactly what went on. And I have yet to meet a team that even that simple blatant attack, some of the detection logic is able to pick, right? And the reason for that is there's so many variants of attacks out there that, signature-based or the rule-based or the scenario-based, right, has a limitation, has a fundamental limitation. So what to do then? So one of the things that we found is we went to some of these skilled analysts, right, whether they had the title of threat hunter or not, right, and we said, we'll give you $250 Amazon gift card if you can find it. And it wasn't the Amazon gift card that did the trick, but they were able to, like 75% of the time when we talked to the senior analysts, they were able to detect that attack, right? So in terms of, we talked about mean time to detect, right? But one of the things that's really hard to measure is what alerts you should have got that you're not getting. And the reason it's very hard to measure, because you're trying to measure a negative statement, right? If you knew what the attack was, right, you'd have been able to detect it. So decision automation is trying to look at those 75% of the analysts and say, how come you did not know what the attack was, but you could figure it out? And there was a pattern that we saw. Underlying, different kind of scenarios, different kind of attack patterns, right? When we looked at how analysts were hunting for that, right, they were looking at data and they were deciding, right, whether it's interesting or not, whether it's suspicious or not, and pulling in all different types of data sources, lookups, enriching it, but then going one step further and saying, based on now what the more information that I have around this particular alert or this particular event, either this is interesting or not interesting. And that's how they were able to fish out 2 or 3 telltale signs of an attack. And so the question we asked ourselves was, if an analyst can do that, if a skilled analyst can do that, can we teach a software system, a machine, to do the same threat hunting? The advantages are obvious, right? Because if you can automate it, it doesn't take 50 minutes. It takes 5 seconds, right? Not just to dig through 20,000 events. You can dig through 20 million, 200 million, 2 billion events. That's the advantage of automation. It's not just 20, 30% better. It's like 100 times more leverage that you get out of the expertise. So that's how the decision automation was born, with the primary purpose of saying, if a threat hunter can find a threat, no matter how deeply buried it is within the data, with automation, how can we teach the machine to hunt? And what we found was that there is a book even called black box thinking. But on the DevOps side, this is a technique that we used to do. Every time something bad happens, right, you ask a question, you ask 5 whys. Why did that happen? And the answer to every why is a factor. right? Why is this event suspicious? Oh, because we're transferring 20 gig of data. Why is transferring 20 gig of data that bad? Because this type of data should never go out there, right? So you're starting to figure out, or we have never seen this user transfer 20 gig of data in 5 minutes, right? So these are all the factors that you're discovering. And so sometimes when people look at, billions of events, and they don't know where to start, right? And it's like, how can I figure out 3 things out of 20,000 things? The secret that we have found, and it's not that big a secret, right? The thing that we have discovered is that you want to find out the factors. And the reality is you can dig out 3 events out of 200 million events based on just a few factors. And so you can take a humongously large data set and boil it down to 12, 10 factors. And then it becomes a very tractable problem because you're trying to build a classifier using those factors. And to illustrate an example, right, what we do is we took a 10 by 10 square of dots, right? Some black dots, some red dots. And what we said was, can you detect the red dot? And almost everybody, when we did that presentation, was very quickly, yep, the one in the left and the top is the red dot. That's great. Now what we did was we ballooned it to like 1 out of 10,000, right? And there is a red dot, but nobody can figure out what the red dot is. And if you further zoom in and turn it into 100 million, right? And if there is a red dot, it's virtually impossible. And this is the difference between, people are really good at finding 1 in 100, but the moment it goes to 1 in 100 million, it doesn't scale, right? So the question is, how do we take that expertise that people can use to detect 1 in 100 and figure out how to fish out 1 in 100 million? And that's really where the multi-factor analysis or the decision automation comes in. So what you do is you take hundreds of thousands of events and you map them along 5, 6 different dimensions. And then along each dimension, you can score them, right? Hey, based on what time of the day the data gets transferred, it's suspicious or not suspicious. Or based on the volume of the data, is it suspicious or not suspicious? Or where is the data going to? Based on the destination, it may be suspicious, not suspicious. From the destination, you can map it to countries, you can map it to organizations, and those are additional factors, and you can score them as well. By the time you have scored on 6 factors, something that is a red on 4 of them will percolate to the top. And so what you can do is by extracting the key factors and by scoring along those key factors, you're able to pick out truly suspicious, truly high-risk things. And you can modulate, right? You can discover new factors. You can modulate the scoring along those factors to further reduce the false positive rates and false negative rates. So this is a very scalable way to build a decision engine, if you will, that you feed data in on one end, and outcomes, here is the 0.001% that is truly actionable signals, right? You should do something about it. And the 99.999% of the stuff that looks normal gets removed. So separating the very important signals from the noise, I think this is a much more scalable and much more understandable way to build a classifier, to build a decision engine. And this is something that we have seen again and again in multiple use cases. It is the same paradigm. Start with events, enrich those events with context, with additional factors, figure out what those factors are, score those factors, combine those factors into a final decision. And you will need to use some machine learning because people are very easy. Like you figured out what the red spot was or what the red dot was right away. But if you have to write a program to do that, you have to use a machine library, right? And most security analysts will not be able to write a machine learning program to detect a red dot from a black dot. But if you use the right library, it's a very simple task to do that, right? So what we have done is we have brought those machine learning Legos. So the security analysts bring in the security domain expertise, and these machine learning operators or the machine learning Legos are available out of the box for them to very easily configure. And we have found that bringing in the domain expertise, bringing in human feedback, bringing in context is a great way to build very deep threat hunting engines, if you will. And we have done things like, looked at massive amounts of GitHub logs, and we have figured out that one account was being used from 84 different IP addresses. And this insight was in the data, but it never percolated to the top. And you build an engine, and it pulls that up to the top. And very similar, like most of the alert triage use cases, is also a similar decision engine. Is this an incident? Is this just an alert? And one of the very common example that Rocky talked about in security automation is phishing triage, right? But what we realized that a lot of people were using, URL analysis, URL reputation, IP reputation, header analysis, and things like that. But one of the companies we were working with, right, one of the most common form of phishing was someone coaxing one of the advisors to transfer some money, right? And so there are keywords in the email that a human analyst just knows, hey, it's phishing. So that is one example where, you're using machine learning to learn the model of, if you see these keywords, it's likely to be a phishing email, and how do you bring it all together to build a decision engine that is as accurate as an analyst. And so we actually did an A/B test, right? We took about 85 emails. One of the analysts took a couple of hours to go through every single one of them and tag them whether it's phishing or not. And we looked at the automation, and it was like 97% plus accuracy, right? So it took us about a couple of weeks to train the model and tune the model and tune the decision engine to deliver that kind of decision accuracy. But what is possible now is that you can match not just the enrichment, how analysts do enrichment, but you can even look at the decision-making that analysts do, and you can automate that itself. And what we're seeing that many companies that had adopted SOAR, that were early adopters of SOAR, are now actually moving in and saying, how do we apply security automation to threat detection and threat hunting? And I think that's truly a new chapter in security automation. So I really enjoyed the conversation with Rocky and the insights on that. And we're going to be at IACD next week as well. So we'd love to connect there and talk some more.
Kumar, Rocky, thank you guys so much. And also, Kumar, thank you for the plug for our Integrated Cyber Conference next Thursday and Friday. And yeah, Kumar will be one of our featured speakers. And for our community, we're glad to have you come on out. Rocky, Kumar, thanks again. And it really meant a lot for us to have you here.
Thank you, Charlie.
Thank you so much for having us.
All right. Well, everybody, we will be back with our next webinar in a few more weeks. And until then, take care. Goodbye.